Dear viewer, welcome to thy favorite TV channel, Hope Channel Kenya, in the program Knowledge Quest, and our subject today is mathematics. I'll be your teacher. My name is Sylvester Omweri. Welcome, and our topic today is formula and variations. So to start with, what is a formula? So a formula is an expression or an equation that shows the relation between two quantities. For example, we know the formula for finding the circumference of a circle. Circumference is given as pi d. This formula is relating to quantities, and that is circumference and d, which is the diameter of the circle. So basically the formula in this case is c is equal to pi d, and that is a formula. It is relating to quantities. The first quantity is the circumference, and the second quantity is the diameter. However, there is another sign that is in that formula, and in this case it is known as a constant. Itself is not a quantity because it is not varying. These others, the circumference and the diameter, that is c and d, we call them variables. Now when we write the formula c is equal to pi d, the first side, c in this case, we call it the subject. While the second side, which is pi d, we call it the rule, with which we are going to use to find the circumference of the circle. Now from that point, I want us to do quite a number of expressions in which we are going to express one variable in terms of the other. So to start with, we're going to start with our first example. In this case, the area of a circle. We know the area of a circle is obtained as pi r squared. Now we want to express r in terms of a. So the question is, express r in terms of a. Already the question in this case is giving us the quantities, the variables, that is a and r, because pi is basically a constant. So for us to express r in terms of a, the first thing you're going to do, let me clean this one here. A is equal to pi r squared. So we want to make a to be the rule while r to be the subject. So the first thing is divide by pi both sides. So by dividing and cancelling, we have a over pi being equal to r squared. But you see, on the right hand side we don't have r, we only have r squared, but on the left is a over pi, and our question is about making r the subject. So for us to make r the subject, we have to eliminate this square here, and to remove that square you find the square root. So find the square root both sides. So by finding the square root both sides, we'll have the square root of, let me clean this initial part because you don't need it again. So we find the square root of a over pi, that will be equal to the square root of r squared. So by finding the square root of r squared, square root of r squared is r. That one is equal to the square root of a over pi. So we can leave our answer as that, Or you can rearrange it to have it as r is equal to the square root of a over pi. So it is something which is so simple. So in this case, we have expressed r in terms of a, because now r becomes the subject, while the second part becomes the rule. That is the first example. Now let's move on to example number 2, so that we can express more in terms of the other. So example number 2 says express x in the formula below, or rather make s the subject in the formula a is equal to bd over s squared minus d. A is equal to bd over s squared minus d. So the first thing, the very first thing that you're supposed to do is to cross multiply, so that we have s, we remove this denominator here by cross multiplying. So the first thing is to cross multiply, and that gives us a into s squared minus d being equal to bd. That is the very first step. Cross multiplying, so that we have s squared on the other side. Now because our s squared, or rather s, is in the brackets, the next step after cross multiplying is opening the brackets. And by opening the brackets on the left hand side, we'll have a s squared minus d, minus ad is equal to bd. Now because we need to make s the subject, remember our question is about making s the subject, so we are going to take this negative ad to the other side, so that we remain with as squared on the left hand side. And by doing so, we'll have it as as squared is equal to bd minus, because it is a negative, when it goes to the other side it becomes a positive, that is plus ad. But still we are not yet through, because we are supposed to make s the subject. And to do that, we'll have to first of all divide by a on both sides, so that we remain with s squared on one side. I think this one is okay, so let's clean the first part because we don't need it again. Let me transfer that so that we have it as a s squared over a is equal to bd plus ad over a. So we can do away with this one here. Now let's simplify. A and a cancel, but on the other side we can just leave it as that. So that gives us s squared is equal to bd plus ad over a. Still we are not through, because the question is about making s the subject and not s squared. So just like the previous example, because it is s squared, you are supposed to find the square root of s. You find the square root on both sides, so that you find the value of s, or rather the subject s as we need it. So finding the square root of s squared is s is equal to the square root of bd plus ad over a. And that gives us the answer, or rather the formula for which s is expressed in terms of the rest. And therefore you have to be very careful in working out the powers and in finding the s that you're required to find. If you leave it as s squared is equal to bd over plus AD over A, that one becomes a wrong answer. You have to complete the question. Let us do another example that requires us to use a different approach. So the question says, apparently it's the same question, but asking about S again. So make S the subject in the formula. So the formula is W is equal to the cube root of S plus T over S. So look at that. It is having a cube root on the other side, and then now we're supposed to find S, or to make S the subject. So the first thing, very first thing, now because it is a cube root, we start by raising both sides to power 3 so that we can be able to do away with the cube root sign. So step number 1, cube both sides. So by cubing both sides, that is step number 1. Now the cube of W will be W cubed. That one will be equal to, now we have the sign, cube root of S plus T over S, then you cube. Now because you're finding the cube root and then you're raising it to power 3, basically what you're doing is simply removing that cube root sign, and we will have it as W squared is cubed rather is equal to S plus T over S. S plus T over S. So we have done away with the cube root sign. So by doing away with the cube root sign, we can now be able to express S in terms of the rest, or rather to make S the subject. I think now we can clean this first part here because we don't need it again. So it was W cubed is equal to S plus T over S. Now by cross multiplying, we will have it as W cubed S, or you can have it as S W cubed, there is no problem. That one is equal to S plus T. But we need S on one side, and therefore we are going to take this S to the other side. Now remember, it is a positive, so when it crosses the equal sign, it becomes a negative. So we will have it as W cubed S minus S is equal to T, because T remains by itself. Now because S is appearing in both terms on the left hand side, you are going to factorize to make it simplifiable. That is W cubed. W cubed S divided by S gives us W cubed, and S divided by S is 1. So minus 1 is equal to T. And now to find S, we'll now simply divide both sides by what is in the bracket. So divide by W cubed minus 1, divide by W cubed minus 1. So you'll be able to cancel this one and that one. And now your answer for S as the subject, so therefore the answer is S is equal to T over W cubed minus 1. So basically that is what you're supposed to do to make a term in to express a term in terms of another. Now maybe you can take one more so that before I can give you one to try by yourself. So the question says make P the subject in the formula. So the formula is P squared is equal to, in brackets, P minus Q brackets P minus R. You're supposed to make P the subject in that formula. So the first thing is, of course, the right hand side, we open the brackets by expansion. So by expansion, we mean you multiply the first bracket with the second bracket. So the first thing, number one, expand the right hand side. Right hand side, the RHS is right hand side. So by expanding, we'll have P squared is equal to P. This P multiplies the whole of the second bracket, that is equal to P minus R. And then the negative Q that we have here is also going to multiply the second brackets, and that is what we mean by expansion. Then do the correct multiplication when opening the brackets, because we know opening the brackets simply means multiplication. So we'll have it as P squared is equal to P times P is P squared. P multiplied by negative R is negative PR. Then we have negative Q multiplied by P. We'll have it as negative PQ, or you can have it as negative QP. There's still no problem. And then we have negative Q multiplied by negative R. Because it is a negative multiplied by negative, we will have it as a positive, and that will be positive QR. Remember, the question is about making P the subject in that formula. That requires us to take all the P's to one side, as we remain with the rest of the terms that do not have P on the other side. And that means all this one here, all the P squared, the PR, and the negative PQ, all of them to be taken to the left hand side, and that will be P squared. Now, because this P squared is positive, when it goes to the other side, it becomes a positive, so minus, or rather, because it's positive, it becomes a negative, that is minus P squared. This one is a negative, negative PR. When it crosses the sign, the equal sign, it becomes a positive PR. And then we have a negative PQ. When it crosses the equal sign, it becomes a positive PQ. Now, because we are done with all the P's from the right hand side to the left hand side, we are remaining with QR over the other side. Now, after doing that, now I think it is so easy to work on P. We're going to simplify first. P squared minus P squared, obviously it's 0. That is like 1 minus 1, which is 0. And then now we remain with PR plus PQ being equal to QR. Let's create more space by cleaning the initial part that we don't need. So we have it as PR plus PQ is equal to QR. So because P is common on the left hand side, we're going to factorize. And now by factorization, we'll have it as P into R plus Q is equal to QR. Same from the previous example, because now we are required to make P the subject, so we're going to divide by R plus Q on both sides, R plus Q. Divide by R plus Q. So by cancelling, we'll have it as P is equal to QR over R plus Q. And that gives us the answer, or rather P made the subject as in the formula as the question was asking. Now, maybe you can now try one by yourself. You can try one by yourself. A very simple one. Just as you checking on that. So the question just before we go to the next segment. So make Y the subject of the formula so the formula is P So the formula is P is equal to xy over x plus y. So the question is making y the subject of the formula, and that is P is equal to x y over x plus y. Be sure to follow the steps that we've done by cross multiplying now, because this one does not have a power or a square root elsewhere. So we're going to simply do the correct multiplication and then correct substitution, rather division and everything, so that you get the correct answer for y. So we have this question here, make y the subject of the formula, that you're going to try as we go for a short break. We'll be right back. Dear student, welcome back. When we were leaving for the short break, I left you with a slight assignment that was talking about you making y the subject of the formula in this question, which is P is equal to xy over x plus y. Now remember, it is making the y the subject of the formula. So I want to believe you got the correct answer, so let us verify with your working. So the first thing is cross multiplying, so that we do away with the denominator. So by cross multiplying, we will have P into x plus y is equal to xy. Now we need to have y, so that we be able to make it as the subject. So first thing is open the brackets on the left hand side. So P multiplied by x, we have px, plus P multiplied by y, we have py. That will be equal to xy. Now we need to make y the subject of the formula, so we will have to put all the y's together. That requires us to take py to the other side. Now because it is positive, when it crosses the equal sign, it becomes a negative, and therefore px is equal to xy minus py. So I can clean this first part here, so that we create space for working. Transfer it here, px is equal to xy minus py. So for us to make y the subject of the formula, we first of all have to factorize y on the left hand side, on the right hand side, and that gives us px is equal to y into x minus p, because y is the common factor for these two terms here. So by making y the subject of the formula, we will divide x minus p on both sides, so that we remain with y on the other side. So x minus p cancels with x minus p on the right hand side, and that leaves us with the answer px over x minus p being equal to y. That way we shall have made y the subject of the formula. So we can leave the answer as that, but as well you can rearrange it to have it as y is equal to px over x minus p. As simple as that, and we shall have obtained our answer as the y that is in the subject as the question was asking us. Now I want us to quickly move on into variations. Now that was the introductory part of the topic formula and variations, and I want us now to introduce variations, which is a very simple concept that somehow we have interacted in our lives here and there. We play games whereby you increase, you vary others. And so basically the topic about variations is something that is so applicable. So we're looking at variations. And the first variation that we're looking, there are quite a number. So the first variation that we're looking at is direct variation. But before that, let me list quite a number. Number one is direct variation. Number two, we have indirect, which is also known as inverse variation. And number three, we have partial variation. And number four, we should be looking at later, is joint variation. And I want us to focus on two of them, or rather three maybe, if time will allow, but we'll start with direct and indirect variation. Now take an example. A vehicle is moving. Just as it starts moving, its speed is increasing from 0 kilometers per hour to 10 to 20. During that period, time is also moving. So that is like, as time is increasing, the speed is increasing. So that is a simple case of direct variation, because both speed and time are increasing. So let's have an example of a table. So we'll have here speed, or rather let's use time in hours, and then we have speed in kilometers per hour. So at time 0 hours, the speed of the vehicle is 0. After 1 hour, we can say maybe the speed of the vehicle is 10 kilometers per hour. After 2 hours, its speed, maybe it's 20 kilometers per hour. So basically what it's telling us here is that as time is increasing, speed is also increasing. So in direct variation, and be both variables are increasing. Both variables are increasing. Like for example, time is increasing as, the speed is increasing as time goes, as time also increases. Let's have an example. For example, now basically the formula for this one here is speed is directly proportional to time. Now what we mean here is that as speed is increasing, time is increasing. Now this one here, there is a sign that I've indicated here. This sign here, we call it the sign of proportionality. The sign of proportionality, which we're now working out, we don't use it because we don't have a value for it. We instead substitute it with a constant. For example, k. Now in this k here is constant of proportionality. Now instead of the sign of the proportionality, we replace it with an equal sign and then introduce a constant of proportionality. That is an example of direct variation, and I want us to do an example. And the example says, given that so it's saying that given that x varies directly as the square of y, and x is equal to 2 when y is equal to 1. So find x when y is equal to 4. So the question is, given that x varies directly as the square, not that, the square of y, and x is equal to 2 when y is 1. So we're supposed to find x when y is 4. Now remember, we said that x is now directly proportional to the square of y. Look at that question. Given that x varies directly as the square of y, so we introduce the proportionality sign so that we are able to introduce the constant of proportionality later on. So therefore x, to do away with this proportionality sign, we introduce equal signs, and then we have a k y squared. Just to remind you, this one here, that sign there is the sign of proportionality. It's just a sign which is done away with and replaced with equal sign and a k, which is a constant, so that you are able to work it out mathematically using now figures, because that sign does not have a value. And therefore now using this one here, we're going to substitute the first statement. We use the first statement so that we can be able to find that constant of proportionality. Now look at that. It's saying that given that x varies directly proportional to this as the square of y, and x is equal to 2 when y is 1, there is a comma. So what we're supposed to do is simply substitute for x and y in this equation that we have formed from the statement of variation. So x is 2 when y is 1. So we have substituted. So 2 is equal to k into 1 squared. So we are basically required to find the value of k. So 1 squared is basically 1. So 2 is equal to k multiplied by 1. So when you divide by 1 both sides, you'll simply have k as 2. So if we were to be asked the equation connecting x and y, you will now bring these two and substitute it in this equation here, so that you will have it as now, so equation connecting x and y will be x is equal to 2y squared. X is equal to 2y squared, because now we have found the value of k. So you substitute it directly. Now this equation here will help us to find x when y is equal to 4. So we now answer the question. So find x when y is equal to 4. Now, which requires us to basically substitute with 4, y with 4, so that we can be able to get x. So x is equal to 2 into y is 4, and that will be 4 squared. So x will be equal to 2 into 4 squared is 16. So the answer for that will be 16 times 2 is 32. Now that is an example to show direct variation. It is a very simple one. Now let us look at indirect variation. Indirect variation, which is the inverse of direct variation. Now remember, when we were starting, we were introducing direct variation, we say that both quantities increase, or one increases, the other one also increases. But for indirect variation, it is the opposite of that. In this case, one quantity is increasing as the other is decreasing. Take an example. Maybe you're approaching a wall. So the distance is decreasing as time is increasing. So as you're approaching a given point, for example, going towards a wall, as you move close towards the wall, the time is increasing, of course, but the distance is increasing. So in this case, one quantity is increasing, while another is decreasing. So you have to be very careful. One is increasing while the other is decreasing. So if we were to write, for example, maybe x, so e.g. x varies inversely. Remember I said inversely is the same as indirect as y. X varies inversely as y. So basically what we mean here by writing it as an expression, we have x, the sign of proportionality. Now in this case is not y, but now we'll have it as 1 over y. So the 1 over y is showing that the y is decreasing when x is increasing, or when x is decreasing, y is increasing. And in this case now, because this is our sign of proportionality, we do away with it. We introduce the equal sign and a constant of proportionality, so we'll have it as x is equal to k multiplied by 1 over y. So as simple as that, and we shall be able to work out problems problems pertaining indirect variation. But I want us now to take an example that has both of these two in one question. And now the question that we have is, so I'm going to write the question. It may be a long one, but let me write. So two variables, x and y, are such that x varies directly as y x varies directly as y and inversely as p. Two variables, or rather three, let's change that. Three variables are such that, so that is x, y, and p are such that x varies directly as y and inversely as p. So we're supposed to find, so if x is equal to 2, when y is equal to 3 and p is equal to 1, so find x when y is equal to 4 and p is equal to 2. So we're supposed to find x when y is equal to 4 and p is equal to 2. So we have three variables. Let me read it again. Three variables, x, y, and p, are such that x varies directly as y and inversely as p. If x is equal to 2 when y is equal to 3 and p is equal to 1, find, so the question is find x when y is 4 and p is 2. Now this question here is combining two variations, that is indirect and direct, all in the same equation. So we know, so x varies directly as y and inversely as p. Now by saying inversely, so we'll divide y by p, and then we now introduce the constant of proportionality, so that we do away with the sign of proportionality. That gives us x is equal to k y over p. So by doing that, we are now going to substitute for x, y, and p, so that we can be able to get this k here. So let's do it. So we'll have it as x, which is 2. 2 is equal to k into y is 3 over 1, because p is 1. So you're supposed to say 2 is equal to 3k. So over 3 over 3, that gives us k to be equal to 2 over 3. After finding the value of k, remember we said x is equal to k y over p. Now because we have k as 2 over 3, we're going to substitute with k. So we have 2 over 3 y over p. Now we're supposed to find x when y is 4 and p is 2. So we simply substitute. So that is equal to 2 over 3 multiplied by y. Y is 4 and p is 2. So divide by 2. So when you multiply that, you'll have 2 times 4 is equal to 8 over 3 times 2 gives us 6. And then you will be able to simplify that to get the answer is as by 2 is 4, by 2 we have it as 3. So the value of x when y is 4 and p is 2 is 4 over 3. As simple as that, we are able to find the value of x. Now remember, we were having the two variations, indirect and direct variation. Now in our next segment, we'll be able to look at other variations, and that will be partial variation and joint variation. That will be summarizing the topic, which is formula and variation. Till then, may God bless you. Have a nice time.